Hello, welcome to our fifth module. In this part of the lecture, we will discuss the principles behind a successful pasture and forage management to efficiently provide sufficient roughages to our large ruminants. At the end of this module, you are expected to differentiate a native and an improved pasture, identify the different pasture utilization system, define stocking rate, carrying capacity, and stocking density, and finally, identify the common grasses and legumes used as feeds in large ruminants. By definition, pasture is any land covered with grass and other low plants suitable for grazing animals. On the other hand, forage is the actual feed, the grass, for example, that is being provided and eaten by the ruminants. As the feed supply is one of the major concerns in ruminant production, one of the big questions or decisions to make before venturing in this production is the availability of land where the pasture can be developed. In the establishment and management of pasture, at least 4 factors must be considered. First is the choice of land. The forage area should preferably fertile, slightly elevated, and have an available water. Second is the choice of forage species. Forage crops to be planted must be high-yielding, nutritious, palatable, and can compete with weeds, resistant to tramping, and thrive under shade. Third is the pasture propagation. Planting should be done when rainy season starts or when rains are regular. Planting materials may either be vegetative cuttings like stem cuttings or root stocks and seeds. There is a recommended rate of 3 to 5 kilograms of pure live seed per hectare for small seed species and 6 to 10 pure live seed for large species. Fertilization of the land must also be considered. And finally, before establishing the pasture, one must already know the grazing management to be employed. Interestingly, pasture can be classified either as native pasture or improved pasture. Native pastures are simply grazing environments that are usually dominated by native grasses and may occur as grasslands or woodlands. On the other hand, improved pastures are irrigated lands where the management objective is to establish or maintain stands of grasses or legumes for the purpose of grazing livestock. In native pasture, kogon and bagokbok are the two most common dominant vegetation, but there are other native grasses present. The dominance of a particular plant over the other is dictated by the site condition and the grazing intensity. Improved pasture, on the other hand, are a major farm investment. Improved pasture is often termed as sown pasture. They can be grass alone, mixed grass, or legumes or pure legumes. Since we now know the basic types of pasture, now let us identify how they are being utilized. In the country, there are at least 3 common types of pasture utilization. First is the continuous grazing. In this type of pasture utilization, the stocks remain in the pasture area for a prolonged period. Continuous grazing is usually employed in native pastures where the stocking rate is low and fencing is often economically impractical. Note that this type of grazing cannot provide good forage yield because the animal cannot be controlled to graze. Second is the rotational, in which the grazing area is divided into a number of paddocks and the animals are moved systematically from one another in rotation. Rotational grazing is practiced in improved pastures. The stocking rate of each paddock is high in this type of grazing, and the pasture is more uniformly utilized. For example, animals are allowed to graze for 3 to 7 days in each paddock, or when 50 to 60% of the area is grazed. Then, the pasture is rested for 20 to 60 days depending on the prevailing growing condition of the grass or legumes. Lastly is the soiling, in which the herbage is cut and carried to the animals. Soiling can support more animals per hectare. In this method, more herbage is produced and available since there is no loss when the animal grazed. Note that this method is more labor-intensive and requires machinery to be more efficient. One of the best protocol of pasture management is to balance the available forage supply with the livestock demand. Or we can ask how many cattle or water buffalo can be stocked in a given amount of pasture area. This can be answered by understanding the principles of stocking rate and carrying capacity. Let us discuss first the stocking rate. Stocking rate is defined as the relationship between the number of animals and the size of the forage resource on which they are placed. Stocking rate is generally expressed as animal units per hectare. For easier understanding, each class of animal in a particular herd has a corresponding animal unit. Although variation exists, in humid tropics like in the Philippines, one animal unit is more or less equivalent to 300 kg live weight. In general, one cow has an equivalent of one animal unit. A bull has a corresponding 1.25 animal unit. Heifer or steers have a 0.75 animal unit. A yearling or an animal between 1 to 2 years of age, regardless of sex, is 0.5 animal unit, and calves have 0.25 animal unit. For example, let us take a look at this sample table provided with a computation on the number of animal units based on the number of heads in a farm. A 48-head herd with 20 cows, 1 bull, 2 heifers, 4 yearling steers, 4 yearling heifers, 2 yearling bulls, and 15 calves has a total of 31.5 animal units. Now we have learned the stocking rate, let us now discuss the carrying capacity. The carrying capacity is the actual or estimated measurement of how much forage a unit or piece of ground is able to produce. There are a lot of computation, but in our case, it can be expressed as the number of available animal unit months or AUMs, or the number of animal units grazed for 1 month. To differentiate it with the stocking rate is the forage demand, while carrying capacity is the forage produced. Carrying capacity can vary from year to year on the same area due to changes in the forage production. It is good to note that the carrying capacity depends upon certain factors such as rainfall, vegetation accessibility and distribution, seasonality, range improvement, and grazing management. Because of so many variables, there is no simple way to quantitatively determine the carrying capacity. We have another term here which can be confused with the stocking rate, the stocking density. By definition, stocking density is the actual number of animal on a part of the pasture for a certain period of time. The most economical way of producing beef or milk from large ruminant is to feed them with quality forages. Sufficient nutritious forages reduce feeding of concentrates, which are way more expensive than forages. Forages provide all the nutrients needed for the maintenance and production of large ruminants except for mineral supplementation. A forage system may include pasture, hay, silage, crop residues, or any combination of these. Grazing is the most economical method for harvesting forages, so a well-managed pasture is a very important feed source. Forages can be classified either as grass or legumes. Grass generally have more structure, thus tend to have more digestible fiber than legumes. They are usually easier to establish in pasture and they tend to have longer growing season, can withstand poorer soils, and respond well to fertilization. On the other hand, legume plants have more leafiness with less structure and often have more protein, energy, and micronutrients as compared to grasses. Legumes enhance ruminal digestion, and some are good source of bypass protein necessary for increased animal performance. In the Philippines, there are recommended forages and they were based on the ease of propagation, wide adaptability, and their suitability as feed in existing livestock production system. Each forage species has its own peculiar characteristics. For example, some forages are erect and tall, while others are creeping or twining. If forages, for instance, are to be used for cut and carry or zero grazing production system, we should use a species that is erect and tall for the ease of cutting. This is true for Napier. On the other hand, forages that are low-growing can be used or intended on a production with a grazing system. In addition, in the Philippine recommends for forage and pasture crops, there's a list of grasses and legumes including their recommended use and adaptability. In this table, we can see whether the forage is recommended for cut and carry or for grazing system. For grasses, Napier, Guinea grass, Paragrass, Pangola grass, and African grass are recommended. For the legumes, Centrosema, Ipil-ipil, species of Stylosantes, and Ceratro are recommended. Same with the grasses, these are just some of the recommendations, and there are more legumes which may be better than those enumerated here. Alternatively, when sufficient forage is not available for grazing, cattle and water buffalo are fed with stored forages such as hay or silage. Hay is a roughage and is usually far from a complete feed. They are actually grasses, legumes, or other herbaceous plants that have been cut and dried to be stored for use as animal feed when there is not enough fresh forage, especially during the dry season. Take note that hay has a poor nutritive value and it is normally added to provide bulk in the ration. On the other hand, silage is a preserved green foliage through fermentation. The process of fermenting roughages is called ensiling. In comparison to hay, silage preserves more nutrients from the original pasture. Nutritional losses are smaller when we convert forage to silage as opposed to hay. However, the process requires consideration of a variety of factors including plant growth, harvest, storage, and feeding practices. And that ends our brief discussion about the pasture and forage management.